Welcome everybody to Monkey Math. Today we're going to talk about derivatives, and more specifically the limit definition of the derivative. So to kick things off, I want to ask you guys a question. What did I just draw here? You might think it's a curve, and to that I'd say you're probably right. But I would also say I think a curve is just a collection of a lot of really small straight lines. If you use a graphing calculator like Desmos, and then graph a curve, and then zoom in a ton on one of the points, you can see it kind of becomes a line. So we're going to do that here today. We're going to talk about why that's significant. So let's say I graph the curve y equals x squared. So let's do that real quick. So let's graph y equals x squared. Right, y equals x squared. Looks something along these lines. I'm not too good at drawing, but I hope you get the gist here. Now let's pick a point on this curve. Okay, we're gonna take this point and we're just gonna call it x. So some input for x. We're gonna be very vague here, very non-specific. And we're also gonna pick another point and we're gonna call this x plus h. H being some other positive number, right? So maybe x is 5 and h is 3, right? So we have 5 and 8, for example. And now let's think, well, what are these outputs going to be? We would have f of x here, and we would have f of x plus h. Okay. Now, if we want to talk about, well, what's the slope between these lines? Or sorry, what is going to be the slope between these 2 points? Well, let's think. Well, m equals y2 minus y1 over x2 minus x1, okay? And if we use these guys, these variables that we just defined, and we plug that in, well, let's see what we get. We have f of x plus h minus f of x. Now, we're going to put this over. Now, if we think, okay, well, now we have x plus h minus x. And if we kind of look at this for a second, we see, well, we have positive x minus x, so those are going to go away, and we're left here with just h. That's kind of why it's just h on the bottom, if you've seen that before. Okay, now we're going to add some zest to this, right? This is just going to tell us what's the slope between, if we were to draw this point here and kind of connect it down here to x. That's just the slope. Okay, great. That's not too impressive, right? But now let's add something kind of interesting. Let's say, well, let's look at this as a limit as h approaches 0. Now you guys might be looking like, okay, this is getting weird now. Okay, now we're adding limits into this. But I want you guys to really think, okay, well, if we say the limit is now approaching 0, that means that this gap is going to be shrinking, right? And it's going to be to the point where if h is approaching 0, we're going to be looking at like this slope, and then we're going to be looking at, this slope, and then this slope, right? And eventually we're going to get to a point where we're just looking at like the tangent line that just hits x, which is what we're interested in. So let's solve this with our function that we're using, and let's see what happens. Well, let's see. That would be the limit as h approaches 0 of x plus h squared minus x squared over h. Okay, let's do a bit of math here. Let's see. We can FOIL this out and get x squared plus 2hx plus h squared minus x squared over h. Now, kind of like what we saw before with our x's, right? It looks like we have positive x squared minus x squared, so it looks like that's going to cancel out. That means that we're going to be left with the limit as h approaches 0 of 2xh plus h squared over h. Now let's look at this again. Well, it looks like we have h on both of these terms, so we can actually factor out an h here, which is now going to be h2x plus h over h. Okay, now that h is going to cancel out. So now we've taken this whole thing, we simplified it, and now we have the limit as h approaches 0 of 2x plus h. Now, this is super important because before, we can't just plug in 0 to figure out what this limit's going to be, because before, we would have been just dividing by 0, which you can't do, right, over h. But now we've turned this into limit as h approaches 0 of just a little term here, right, just a little expression. So now we can just plug in 0 and see what we get. Well, in this case, this is going to be equal to 2x. Okay, if we plug in 0 over h. So this tells us that with whatever point we plug into x squared, we can find its instantaneous rate of change or the slope at that point using 2x. And this is why we say that the derivative of x squared is 2x, because of this definition. So for example, let's choose the point, points 2, 4, right? If we're gonna draw the tangent line that hits x equals 2 at y equals 4, let's try to draw this the best of my ability. It's a terrible drawing. I butchered that horribly. But the idea is that this line right here is going to have a slope of 2 times 2, which is 4, right? So 2 times 2 is equal to 4. Therefore, right here, the slope would be equal to 4 on that line that we just drew. So this is a very brief introduction. There's so much more we could talk about, but I want to keep things simple. I really hope that helped. I hope calculus isn't too overwhelming right now. I hope you guys are kind of getting it. But if it is, don't worry. Monk Main Math is here, and we're going to cover many more topics in future videos. So I hope that helped. I hope you guys have a great day. Love you all. Bye-bye.